welcome everyone. Just a quick heads up here. We are using GoToMeeting, as you guys can tell, for this webinar. And apparently they had an outage earlier today, and so they just came back up within the last hour. So hopefully things will stay up. We won't have any issues, but if we do, just to let you know, if for some reason the service goes down and we can't continue, we will send an email out to everyone that's registered with information about some sort of follow-up session. So anyway, okay. So Mary, somebody has an audio issue. I don't know if you can chat with them. Okay. So I guess we'll go ahead and get started here. So again, welcome. My name is Brock Allen. I'm from Developmentor. This is our webinar on WebAPI, or ASP.NET WebAPI. I'll just call it WebAPI from now on. It's easier that way. Just a little bit about me. Like I said, I'm from Developmentor. I've been teaching for 12 or 13 years now for Developmentor. There's my website where I blog on ASP.NET, WebAPI, and web-related security topics. I also do a lot of open source work, so you can see the types of projects I work on there. The slides and demos for this webinar are going to be available at this URL. And for those of you who are already in here, I'll go ahead and paste that in to the chat window so you guys all have it. And then at the end, I will paste it again for people who come in late. Okay. Right now, there are no demos up there. The slides are up there, though, but I will make everything available at the end. Okay, so the webinar today, we're going to talk about WebAPI and what WebAPI is all about, and just in general what WebAPIs are, and then this other thing called REST, which is a very common term that's thrown around when people are developing these HTTP-based services. And I'll talk about kind of what that really is and how that relates to WebAPI. And I'm talking about two types of things. When I talk about WebAPI with capital WebAPI, I'm talking about Microsoft's framework, and that's majority of what we're going to talk about today. But then there's also this concept of web APIs in general, which is more of a loose term that really is not specific to Microsoft or any particular vendor. Okay, so anyway, Microsoft's web API is an implementation, if you will, or a framework for building these things called web APIs. And then we'll see how REST fits into that. Okay, so really what we're going to do is talk about Microsoft's implementation, and we're going to spend the majority of the time looking at building these services with WebAPI or ASP.NET WebAPI. And then at the end, what I'll do is I'll show you how to actually build a client. And most people probably here are web developers, so I'm assuming most people are familiar with Ajax. So I probably won't show that, but I will show Microsoft's client library from .NET and how you can use that to then connect to your web API. Okay. So anyway, that's sort of the agenda. I guess we'll just dive in here and talk about what is web API all about. So Microsoft ASP.NET Web API is a framework for building HTTP-based services, and that's basically what the lowercase web API means in the industry. So people want to build services where you can have code communicate with other code, servers to servers or clients to servers, whatever the case may be. And so we've had lots of frameworks and technologies in the past for doing this. We've had like RPC way back in the days, and we had COM and DCOM. And then for a while people moved to SOAP as a service-based architecture. And sort of, all of those have had their successes, but then the next one here that we're facing these days is basically HTTP-based APIs, or like I said, generally speaking, web APIs. And so really what has made this style of service popular is the success of HTTP and HTML. So one of the really big things about HTTP and HTML is that these things are ubiquitous. Every platform these days has an HTTP stack, and therefore can do network communications. So HTTP is actually a very, very simple protocol for doing distributed communication. Now again, HTML and browser-based applications is sort of the traditional historical use case for that, but people have discovered that they can use this also for service architectures. Okay, and so one of the really important characteristics of HTTP as your service architecture is that it's very simple, and like I said earlier, it's ubiquitous. It's on pretty much every platform, right? Mobile devices, iPads, tablet devices, the Amazon readers, whatever, right? And of course, on desktop apps as well. So that's the fundamental architecture here. Is for web APIs, we're going to be using this really, really simple protocol. Okay. So HTTP, the interesting characteristic about how web APIs in general use HTTP is you want to think about HTTP not just as a pipe to send bytes back and forth on the network. Okay. Instead, HTTP is sort of elevated above sort of what you would think of like just a socket connection. And instead, what HTTP is in this web API style of coding is that HTTP is actually embraced as not just a network protocol, but it's actually part of your application protocol. So in other words, what I mean by that is HTTP, which was invented some 20 plus years ago, they built into HTTP that long ago the ability to transmit things like error messages, status codes. They have a mechanism for passing out-of-band data, headers. Okay, they have a standard approach for doing security, authentication, and so that aspect of HTTP is actually going to become part of your application or your service architecture. Okay, so in other words, anytime your application or your service needs to emit some sort of error code back to the caller, then the style in Web API is to leverage what HTTP already has rather than inventing your own error message format, if you will, on top of HTTP. Okay, so that's the fundamental style with Web API style services. Okay, so to embrace HTTP, well, actually, just before I get there, again, I mentioned these already. Some of the characteristics of HTTP which make it desirable as a service platform is super simple. It's text-based, request-response protocol. They already define a lot of the different kind of things you need in your application semantics, like I said, errors and headers and things like that. HTTP is definitely scalable, right? I mean, think about the web, it scales really well. And part of the characteristic of that is that it is stateless protocol. And so that's a very, very useful way to build scalable applications. Reliability is another big part of that, right? I mean, things fail all the time, and so you have a standard way of sort of dealing with that. And then also what's nice about this architecture is that it's fairly loosely coupled. So again, pieces can evolve over time independent of each other. Okay? And I'm going to talk about this thing called hypermedia here in a minute. So to think about then building a service that incorporates these characteristics of HTTP, you kind of have to think about, well, what is HTTP all about? And that helps influence the design of your service. Historically, services in the past, or at least in the recent history, on the Microsoft platform, people use SOAP. Okay, SOAP is very, very popular. The popularity is sort of fading, I would say, in favor of these HTTP-based services. SOAP is fairly complicated, and in essence, it's kind of people use it as like an RPC mechanism, a way to invoke remote methods on remote services. It is a bit of a messaging protocol, right? I mean, that's a fundamental characteristic of that is that's the design, but people think of it as just a way to invoke remote methods. So to change your style and adopt more of a web API or a HTTP-based architecture, you kind of have to shift your thinking. And so to think about how to design your service in this world, it's helpful to kind of think about how HTML and HTTP relate to each other. Okay? So if you think about the way the web is built, the web is built on resources. So this idea is that when you use your browser to go hit the web, you're basically asking for a resource, right? That resource may be an HTML page, it may be an image, it may be a PDF document, whatever. And so that's the kind of the fundamental premise of how browsers work, is that you're accessing resources over the network. You're not thinking about things in terms of objects and method calls, you're thinking about resources. Okay, so that's a really fundamental part of this HTTP-based design. Now, of course, to locate those resources, we need a way to address those resources. So we have this concept of URIs or URLs. That's basically a location that you can point your browser at to go find this resource. So if you're going to be building your services, then you're going to, of course, have URLs to identify the endpoints for your service. Now, in terms of the types of things we do with these resources that we can then identify or address with URLs, we think about sort of the resource-oriented operations. Okay, so in an RPC SOAP-based world, we're thinking about method calls across the network. Whereas with this HTTP-oriented approach, we don't really think about method calls per se. Instead, the way HTTP describes the operations that you are allowed to do on these resources is via the HTTP methods. Okay, so the common HTTP methods that we have are get, put, post, and delete. Those are the four common ones. There are others. But in terms of thinking about resources, that's how HTTP expresses the type of operation you want to do. So if you're trying to read a resource, you're going to use a get. If you're trying to update a resource, you're going to do a put. If you're going to delete a resource, then you use delete. And then the last one is post. And post is kind of a loosey-goosey HTTP method that's open for interpretation. A lot of times post is used for the concept of creating a resource. So post tends to do creates. Or if there's some other type of thing you're trying to express and none of the others model it very well, then typically what we use is post. Okay? So HTTP methods are going to be really important to this whole style of coding. Of course, I already talked about the way we indicate the outcome of a request is we use the HTTP status codes. So again, your application is going to be, or your service that you're building is going to be embracing these status codes as a way to report back the outcome of a request to the caller. Okay, so you're going to basically learn a lot about status codes and figure out, oh, well, this one's appropriate for this scenario, and so on and so forth. So again, you tend to want to leverage as much of this infrastructure as possible. Of course, I talked about headers as the way to send out-of-band data. So these main things here that I've listed, up to hypermedia, but not including, are just the basic concepts that we have when you're building HTTP-oriented services. Okay. Now, a lot of times, people call WebAPI or these web APIs in general, they call them RESTful services. And that has a certain connotation to it. Okay? A lot of times people use that term incorrectly. Okay? So up to this point, I haven't really described anything that is considered RESTful. I've just simply described HTTP-oriented services, or like I said, just simple web APIs. Okay? So those two terms are appropriate for what I've described up to this point. The concept of REST is basically a style of building an HTTP-oriented service or a web API. You don't have to use REST to build a web API. You can build a web API or an HTTP-oriented service that's totally successful without making it RESTful. Okay? So what it means to be REST is basically the inclusion of this concept of hypermedia. So the hypermedia idea is sort of driven based on how web pages work. Okay, so if you think about how web pages work, let's say you go to Amazon.com and you are logged in and you see the list of the orders that you've placed. So you have some book that you ordered. So next to that book, there are operations that you can perform on that order that you had placed. Okay, so one operation might be the concept of canceling an order. Okay. So the idea there is that if you have an order placed and you change your mind, you have the ability to hit cancel. Okay? So the thing with that, though, is that that cancel button is only going to be there if the order has not yet shipped or been completed. Okay? If the order has, in fact, been completed, then it's too late to cancel the order, and you won't be presented with a cancel button. Instead, you will be presented with maybe a return button or a view receipt button or something like that. But basically some other operation based on the state of the system. Okay? That, loosely speaking, is the general concept behind hypermedia. What's happening is you are looking at some data. You're looking at your order. And the set of operations that you can perform on that order depend on the state of the system or the state of that order. Okay? So depending on the state of the order, you can either cancel it or you can return it. Okay? So the system is dynamically giving you back buttons or options or operations that you're allowed to perform based on that state. Okay, that's the concept of hypermedia. Hypermedia is, in a service-oriented architecture, is when you get back data, some sort of resource that you're trying to access. Okay, the resource will have the data that you are interested in, and it will also have attached to that operations. Okay, and these operations then give you the list of the things that you're allowed to do on that resource based on the current state of the resource. So hypermedia is the thing that's typically missing when people build HTTP-oriented services, and then they call them RESTful services, and incorrectly calling them RESTful services. So again, this is a very technical, and maybe an overly pedantic description of things. People use the term REST. By the way, REST stands for Representational State Transfer, and that's essentially all of these other things plus hypermedia. Okay, and so it's all founded on this concept called HADIOS. There's no real proper pronunciation of this, but it's an acronym that stands for Hypermedia as the Engine of Application State. Okay? In essence, it's what I described. It is the data you're getting back from your service. In addition to the data, it has these links that are the operations that you're allowed to perform on that resource based on the current state of the resource. Okay, so technically speaking, that's what it means to be RESTful, is that if you include hypermedia in your service, in the resource that you're returning from your service. Okay, like I said, it's just a style. You don't have to use it. That's totally fine. It's just that technically it's incorrect to call your service a RESTful service if you're not including hypermedia. Now, having said all of that very pedantic sort of level description, people misuse the term all the time to the point where it's actually hard to actually make heads or tails of it. It's hard to actually tell when somebody says, "Oh, I have a RESTful service," or "I'm implementing a RESTful service." It's really hard to tell if they really are or not. So usually when I hear the term RESTful service, I basically assume that people aren't using the pedantic, very detailed-oriented description, and really what they mean is they have an HTTP-oriented, web API. If I hear the term, we have a hypermedia-driven system, or we have a hypermedia-based API, or something like that, then that clues me in a little bit better that they are supporting this concept of hypermedia and the HADIOS sort of style. Okay. Again, though, you don't have to be using hypermedia. It's just a style of building web APIs. Okay. I'm going to check out the questions here because that's kind of a interesting topic, but no questions so far. Okay, good. Oh, we do have questions. Sorry, I couldn't see them all. All right. Okay. Audio. Bunch of audio. Okay. Sorry about that. Okay. Good. I will continue on. Okay. So, related to this concept of hypermedia, basically, like I said, you could be building a web API service that does or does not support hypermedia. And so there's this thing called the Richardson maturity model, which is basically sort of like a grade. How close are you getting to building a RESTful service? Again, maybe this is a little pedantic, but there are basically various sort of levels. And if you have gotten to level 3, where you're using hypermedia and you are using multiple HTTP methods and you are using multiple URIs, then technically this is when you have achieved RESTful design. Okay, I won't bother going over that anymore. So, all right, so let's dig in and actually talk about using ASP.NET Web API to build these HTTP-oriented services. Okay, so a common point of confusion is sort of the relationship between MVC and Web API. So MVC is a framework for Microsoft for building browser-based applications. It is very much HTML-oriented. And what that means is that most of the framework is designed for generating web pages, HTML pages. Although, of course, that is, of course, over HTTP. Web API is a different framework. It has no dependencies on MVC. That is a very common misconception. It has no dependencies on MVC. They are entirely different binaries. They're different DLLs. They're different assemblies, and they don't have any dependencies on each other. Okay. So that's a very common point of confusion. WebAPI is also an HTTP framework for generating responses to HTTP requests, but it's much more about the services that we're going to be building, less about building web pages. Okay, so in a sense, WebAPI is actually a little bit more general than MVC, because WebAPI is about a little bit lower level, if you will, about the HTTP level, whereas MVC is much more geared about HTML. Okay, so you could build your own HTTP-oriented services using MVC. That would totally work, and you wouldn't necessarily need WebAPI. The way I kind of think about it is, if you want a service that is being invoked from your own HTML pages from JavaScript over AJAX, and that's the only exposure your services have, and they're not meant to be used by like third parties or business partners, then MVC might just be totally fine. Way to go. But if you want to have a more formal service that is going to be used by third parties or, like I said, business partners or integrations, that kind of thing, then WebAPI is probably the way to go. Okay. Then if you've built a WebAPI, then your own web pages could invoke your own WebAPI. That's totally fine. Okay. So anyway, that's kind of the relationship between the two. All right, so let's go and talk about this. So having said that, by the way, just kind of going back here, talking about the relationship between WebAPI and MVC, WebAPI was heavily inspired by the design of MVC. So you're going to see many of the same patterns in WebAPI that we have in MVC, and even some of the same class names. Like there's an authorize attribute, there is a model state property. They have the concept of model binding. Very, very similar concepts, but it turns out they're totally different implementations in WebAPI than they are in MVC. So again, don't let the similar names confuse you or lull you into a sense that this is actually MVC. It's not. So having said that, again, they do behave very similarly, but in some scenarios, WebAPI, their implementation is more catered to what WebAPI needs to do. So they don't behave all the same as they do in MVC. Also related to that, the sort of downside is that if you build something in MVC for reuse, like you build your own authorized attribute, say, for security, it turns out you cannot reuse that in WebAPI because they're totally different frameworks. So you would have to re-implement an authorized attribute in WebAPI then, separate from the one from MVC. Okay. All right, so let me go write some code. That's, I think, I've done enough talking here. So let's go run Visual Studio. And so what I'm going to do is go and build a new project. Now, having said that MVC and WebAPI are totally unrelated, and they are different frameworks, they are actually written by the same developers and the same team at Microsoft. So there's actually one team that's in essence responsible for both projects, or both frameworks at Microsoft. And what they did, which is totally confusing, is they bundled the wizard, if you will, the project template for WebAPI, they bundled it with MVC, okay? Which again is confusing for people. I think they were assuming that people would be building one project that is hosting both MVC and WebAPI. I think that was sort of their positioning. So I'm going to walk through the wizard using their templates. You actually don't have to do it this way. You could totally start with your own empty project and just add WebAPI. By the way, WebAPI is distributed via NuGet. So it is not tied to .NET. It is not tied to any releases of Visual Studio or anything like that. It is shipped via NuGet. So that's how you obtain the libraries for WebAPI. Of course, there are tooling in Visual Studio that syncs up with that, but that's the actual distribution, and that allows them to fix bugs and do patches. And also the other thing about this, by the way, is WebAPI is fully open source. You can go look at the code up on Codeplex and see the code. You can see all the check-ins and all the issues and all the comments and all of that. So, or you can even build it yourself. But anyway, let me go and start here. So I'm going to do an MVC4 project, again, which is confusing because WebAPI is unrelated to MVC. And then what I'm going to do is use the WebAPI project template. Okay? And what this does is it sets up a template that automatically references the NuGet packages. Okay? The other thing about this template, which is confusing, again, it's the only WebAPI template in here, is that this template, in addition to referencing all the NuGet packages for WebAPI, it actually also references all the NuGet packages for MVC. So in other words, this template is both WebAPI and MVC. Again, I find that to be pretty confusing. And a lot of times, especially if you're building a WebAPI that is just intended to be services for, say, a business partner that they're just invoking directly, then you may not even have any HTML pages or any UI of your own. So having all this MVC stuff in here is actually a lot of the times not needed. So what I'm going to do is I'm going to delete all the stuff I don't care about. So app data, we don't need that. Okay. Areas, that's an MVC thing. Content, those are like CSS. I don't need those. Controllers, images, models, scripts, views, favorite icon. Okay. None of that stuff I need. Okay, so I'm going to get rid of all that. That probably is not the right way to get rid of the stuff. I probably should have done the NuGet remove package, but just for sake of convenience, I'm going to just do it that way. Okay, I don't need bundles, filters, or route config. Okay, so what are we left with? Well, pretty bare bones project. But again, the big thing here is that I have the references to system.web.http. That's the primary library for WebAPI. Okay. There are other ones as well, like if you're hosting WebAPI out of IIS, you're going to need the system.web HTTP web host assembly as well. Okay, there are a few others in here as well, formatting, things like that, and we'll talk a little bit about those features. They typically, you think of them all just bundled together. So what we're left with is essentially a global ASAX. We're going to need that. Okay, we're going to need that because we need the app start. And the app start needs to basically do the Web API initialization. So following with the MVC convention, they have this app start folder where we have our initialization. Okay, so I'll actually show that to you right now. So the initialization here, the main thing of interest is the routing. Okay, and again, this configures the URLs that we will be accepting in this application for our web APIs. Okay, so again, very similar to how MVC works. What they've done is they've configured their own extension method called map HTTP route, where they set up then the route template. This is the URL template that we'll be accepting. And again, it looks a lot like the one we get from MVC. Notice they prefix theirs with some static API content there at the beginning of the URL. Totally fine, and that's a fine convention. I actually tend to follow that one myself. And then what they put in here is a placeholder for the controller. So the controller is going to come in through the URL. So WebAPI, like I said, is very much influenced by MVC's architecture, and what we're going to be creating are controllers for our resources. And again, if we think about HTTP, we're typically thinking about resource-oriented sort of service. So our controllers tend to represent resources, whether it be customers or orders or whatever. Now, we have the typical ID parameter here. A lot of times when you're accessing your resources, the URL is going to be something like / I don't know, whatever, people or something like this. Okay, so, and then you might get a specific person, maybe based on ID, person ID 1, or maybe just based on their name, like Brock or something like that. Okay, so that's kind of the pattern with the URLs, is the URLs allow you to reference the resource, and then optionally a specific ID. Now, an important thing here that's missing that MVC has is, typically in MVC, then you would also see action. And action is typically the method on the controller. Okay? In WebAPI, we don't have this because we talked about the concept of actions are not things that you put in the URL. What the URL represents is the identifier for the resource, and that typically does not have a verb in it. So if your URL looks something like, people/update/1, that doesn't tend to jive with the whole RESTful style, or even just the HTTP-oriented style. Okay. Again, what we rely upon are the HTTP methods. So if you're going to be updating something, actually let me put that back. then you would just reference the identifier for the resource, maybe again it's just Brock, and then what you would use is you would actually use the right HTTP method, okay, to actually update that. So it would be a put for this particular resource. Again, put with the semantics of update, right? So that's why we have action is missing in the URL. Okay. Again, if you happen to see verbs in the URL, then that just feels a little funny, given the whole resource-oriented nature of HTTP. All right, so let's go build a controller. So what I like to do, just because WebAPI has this API prefix, I like to have a subdirectory called API. I don't know why. That's just sort of a style thing. You can do whatever you want. In the template for MVC, or I'm sorry, the WebAPI template, the one I just deleted, they actually leverage the controllers directory, and then they mix both MVC controllers and WebAPI controllers in the same directory. Personally, again, I find that to be kind of confusing. So I like to have separate folders. So I don't know, I'll call it API. Okay, so what I'm going to do is, what am I going to do? I guess I'll model data. So actually, you know what, I'll do some real data. So I actually have a SQL Server here. I think I have my Northwind database, which is my favorite demo database because it's so exciting. So let me go to Northwind. I think I have a products table, something like that. Yeah. Okay, just make sure I get some data. I can connect. Yeah, okay, good. I have a bunch of products. So what I'm going to do is I'm actually going to quickly scaffold some access to that. So I'll just go do some entity framework code. I probably should have done this earlier. So bear with me. I'm going to do this. I'm going to access Northwind. I'm going to pull in data from that database, localhost. Use Northwind. Okay. Right, next. I'll pull in the products. Okay, finish. Okay, good. Hopefully that all worked. Okay, good. So this is just quick data to a database. I just wanted to show some live data. That makes it a little bit more interesting. Okay, so that's great. So what I'm going to do then is I'm going to now create a controller to access that database. So that's over back on my API controller, or API directory. I'll create a new controller. Again, you don't have to use this little wizard here or not. It's up to you. But again, the MVC team is the same team as the WebAPI team, so they bundled the adding of a controller, both a MVC controller and an API controller into the same wizard. You don't even have to do this. You could just create a class that derives from the right base class. So I'm going to create a API controller called products, and this is going to model my products out of my database. Okay. So notice we derive from API controller. Again, same pattern as MVC. We have a special base class, except this is not the MVC controller base class. It is the WebAPI controller. So what we do is we provide methods. I think they even still call these action methods. Actually, let me go add my model.northwind context here. Oops, wrong thing. Northwind entities is what they call that. Okay, so we'll grab this. Oh, I need to put it in my class, sorry. And so this is going to be my database. Again, just going to access that. How you design access to your database, again, it's totally up to you. Probably would rather see like a repository pattern of some sort. Okay, so what I'm going to do is provide action methods. And these action methods are going to be the methods that are invoked when we make these requests to these HTTP endpoints. These action methods, then, are going to be named based on how we indicate operations in HTTP. So, since if you want to do a read request on the product resource, you're going to do an HTTP GET. Okay? So that's the idea here, is that your action methods are going to map to the HTTP methods. Okay? So what I'm going to do is I'm going to have my GET, and it's going to return all my products. So there are a couple different ways to return data. Here, one way is I can do an IEnumerable. I can just actually have my return value of my actual product data. So what I'm going to do is I'm actually not going to return my entity framework classes. Okay, these are an internal implementation detail, and in general, I find it to be a bad practice to use your entity classes as the same things that you put onto the wire, onto the network. So instead, what I'll do is I'll actually just create a simple product data class that represents the data I'm simply modeling at the boundaries of my service. So I will have a product that has a name, and I'll have a product that has a price, something like this. And actually, you know what? I think that is nullable in the database, so I'll go ahead and just express that here nullable. So that's what I'm going to return here, is my product data. And so what I'll do then is I'll simply write a query from p in db.products. We're going to do select new. What do I have here? Typically this is called a DTO, data transfer object. And price equals p dot unit price, like that. Okay? Great. So I'll do a build. And, oh, I never returned this. So I'll do return query dot, to array. I'll trigger the link execution right there. All right, good. Simple stuff. Let me now run this. So I'm going to run this in my browser. Normally your browser isn't going to be directly hitting these URLs, but just to have something to access this, I will go ahead and use my browser. And I will come into /API/ hey, looks like I have it there, products. And what we end up with is, hey, a bunch of data. Okay? So we ended up hitting this endpoint. Okay? The URL scheme here basically was API, products, like that, right? And that was the URL. The ID part I didn't provide. I wasn't accessing an individual product. I was more accessing all of the products, and that's why I got that that URL mapped. The verb was the HTTP method rather was a get, and it mapped onto this code. This then returned a bunch of objects, and the WebAPI framework is converting these objects to the resource representation here as XML. Okay. So you might ask, why is this XML? Well, that's another piece of how HTTP works. So I got XML here. Let me go over to another browser. Let me open up Firefox real quick. And I'm going to paste in the same URL. Okay, and notice over here, I ended up getting JSON. Okay, so JavaScript object notation. So what's happening here is that in WebAPI, when you return results or data, WebAPI does something called content negotiation. Content negotiation is where WebAPI basically will then figure out what the client prefers in terms of format, and it will take your data and serialize it out in one form or another. Okay? Now, what controls this? How do we actually know what the client really wants? Well, it turns out that pretty much all browsers, and this is how HTTP works, is that anytime you make a request on the network for some sort of resource, what happens here is there's an HTTP header that browsers send called accept. Okay? And this is what the browser is telling the server that it prefers in terms of formats. So what it's saying is it would like to have HTML, okay, or XHTML. Those are its top two preferences. Okay? If you don't have those two, then it will take plain old XML with this Q factor, and the Q factor is sort of your level of preference from 0 to 1. So this is a 0.9 preference, so it's not preferred as much as the other two. And then the last thing it provides you here, I'm going to switch to red, is this last one, which is star.star, which is very optimistic of the browser. The browser says, if you don't have HTML, XHTML, or just XML, then I'll take anything else, whatever else you have, but that's my least favorite, if you will. Okay? So notice what happened here is my server, we don't have any HTML, so neither one of these got sent. But built into WebAPI is something called a media type formatter. And they have a few media type formatters built in. They have one for XML and one for JSON. So since this client said, hey, I'll take XML, and nowhere in here did it say JSON, then WebAPI said, okay, that's the one you prefer, we'll turn it into XML for you. Now, going back over to Firefox, I suspect, if I look at my network call here, if I hit refresh here, if we look at this request, if you look here, notice the request headers here. I have very similar as the other one, right? We have HTML, we have XHTML, we have XML, same as the other one, but notice this one is 0.8. And then we also have in here JSON. Okay, and that one's 0.9. So since the 0.9 is bigger than 0.8, then this one is marked as the one that was preferred, and so my server honored that and returned JSON instead. Okay, so that is actually something I have explicitly configured in Firefox. Firefox doesn't come this way by default, but I like to see stuff in JSON format sometimes, so it's sometimes easier to look at than XML. So that's why I've configured Firefox. So just if you care, if you go to About Config and you look for the accept header, then you can actually see what the default header is, and you can come in here and change this. So I went in here and changed this, and I added in JSON. Okay, so you get the idea. To do that in Chrome, I think you have to get a plugin. So that's enough of a hassle that I never bothered with Chrome. But Firefox is nice and configurable, so I was able to do that directly with Firefox. Okay, I've talked about a lot of stuff. Let me go over here and see if I have a bunch of questions. And sorry if these are a little bit from earlier. So when developing ASP.NET MVC with the option of WebAPI, would you suggest using WebAPI as the way for application to handle processing, or should we use WebAPI for creating services for others? Again, that's a tough call. I can't tell you, absolutely do one or the other. Like I said at the beginning, I think if you're going to be doing services just for your own application from like your own JavaScript, then you could do MVC, or you could use WCF. That's entirely up to you, or WebAPI. I mean, that's really sort of up to you in terms of kind of what your reach is. I'll tell you that if the client that you're building is just JavaScript, then JSON tends to be a little bit easier to consume, and therefore, a HTTP-focused sort of approach tends to be perhaps a little bit easier. Also, if your client is a device like an iPhone or an iPad or even an Android or a Windows phone, then again, those tend to be easier to code against just simple HTTP with JSON. It's not to say there aren't SOAP frameworks on like the iPhone. There are, but again, it's it just feels a little bit more cumbersome if you just need data back and forth. The other thing about that is that SOAP provides a ton of other features like transaction support and some crazy security support. And if you don't need that, then you're sort of buying into a framework that has a lot of overhead that you may or may not be using. So it's a really tough call. I don't really know the right answer. It's just going to sort of depend scenario by scenario. I got to say, the tooling tends to be really easy with WCF. But again, there's always the configuration hassle. So for me, these days, I would tend to choose a more HTTP-oriented service, again, mainly because of the flexibility and the openness. The whole SOAP approach, unless you're absolutely doing .NET to .NET, like a console app to your service, and there's no browser and there's no web really involved, then WCF still can be useful, especially with the nice tooling. Okay, that's totally not a good solid answer for you. I apologize, but it just kind of depends scenario by scenario. Okay, good. Oh, Jason, I already answered it. Sorry, I didn't see your follow-up there. Okay, how do you map when you get two actions by ID and by name? Yep. So in these controllers, you can actually put in the name of the action. So you can affect the URL, so you can go in here and add this concept of an action, and you can start to morph the routing model, or if you really wanted to, you could put in an action parameter here, like that. Okay? I don't tend to do that. I tend to think of each controller as a resource, although for this scenario, like by ID, by name, perhaps those are the same resource. But anyway, there is a way to put the action in here where you can have the URL indicate those different things. The other thing, which is also commonly done, or which I find myself doing, is I just create a whole new controller. So maybe it's products by name. Maybe that would be another approach. Okay. All right. If you add serializable attributes to your class, can you have extra fields that aren't returned but are still in your class object? Yeah, there are ways. So the two built-in media type formatters, Chris, that I mentioned were the JSON one and the XML one. So the XML one uses the data contract serializer, which actually comes from WCF. So you can use all those same WCF directives to say which which properties to include or exclude. The one for JSON is actually from Newtonsoft. So they actually adopted, if you see here, it's actually newtonsoft.json. The WebAPI team adopted this open source JSON serializer because it was pretty popular in the community. So there are actually now 3 different JSON serializers that are being used by .NET. There's the one from WCF, there's the one from ASP.NET, and now WebAPI is using this 3rd one. So anyway, this 3rd one, the Newtonsoft JSON, has a way to then put attributes on a class, and it's like JSON ignore or something like this. I'd have to go look them up. There we go. That's it. So JSON ignore, right? There are attributes like this that you can put to do it. The funny thing, though, is that again, the 2 different media type formatters, you're going to have to put the 2 different styles of attributes depending on which serialization you get. Okay, can I add a WebAPI controller to an existing MVC app? Absolutely. So you can add in WebAPI if it's not already there. All you would need to do, let's say this were a plain old MVC project, you could then do manage NuGet projects. You simply go and look for WebAPI. And in here, you would simply grab Microsoft ASP.NET WebAPI and hit install. Okay, and this is the one that we already got automatically by doing the WebAPI template. But if you had one that didn't previously have WebAPI, that's the way you'd add it. And then the only other thing you'd need to do, by the way, is you would have to add in the map route. That would be the only additional thing that the wizard wouldn't do for you if you were adding it purely from scratch, not with the template. Okay. Ranges for the product controller. You mean like queries, like filters. So this supports like model binding, kind of like MVC does. So you can take parameters here, like, I don't know, string name or something like this. And so if your parameters here are simple parameters, primitive types, then these get model bound from the query string. So you can have a parameter like name, chai, or something like that, okay? And then you could use that in your query, okay? So you could say where p.name maybe contains name or something like that, whatever you want your query to be. So you can take parameters, that's totally fine. So your endpoint here can have normal query string parameters. That works fine. Okay. All right. By name explained it. All right, so in WCF, fault contracts allowing the client side to receive exception, is it similar to transfer error client side out of the box, or is it left to be customized by the developers? So absolutely, you can have a control over the response. So actually, let me show you doing that. This is a good way to segue into the next thing. So I'm going to put your questions on hold while I show the next thing, and then I'll come back and get to them while I'm sort of answering this question. So let me add another one here, public. Let's do product data, get, where we then take just based on like a product ID. Okay, so maybe this is what we want to serve up as a product. So what I would do, then I would basically write a very similar query, except I would put my filter in here, where p.product ID is equal to ID. Okay, great. So I'm going to pull back my product data. Now in this case, I'm going to get my product, and this is going to be query dot. Let's do singular default. And then I'll return product like this. Okay, so this should work as well. Let me run this. Run it in the browser. Come back in here to API product and do. There's the regular set of products like this. That still works. And then I do /1. Right, that's chai or tea. Okay, so that totally works, and we got back the one product. Okay. Of course, what happens if we do, I don't know, 99999? I don't think we have that one. Okay. So the funny thing about this is we got back. Weird. What we got back was this XML document that says nil of true. Okay. Now what this is that's the data contract serializer from WCF that is taking a null product data and serializing it, and that's how they serialize that kind of thing. Okay. That's not very HTTP friendly though. Normally in HTTP, what we would expect is if this URL didn't find anything on the server, you would expect a HTTP status code of 404. But what we ended up getting was a status code of 200 OK. Okay, so this doesn't really line up. This doesn't make a lot of sense. Okay, so what we have, instead of this higher level API where you return objects, I don't tend to use this approach. People demo it quite frequently, especially at conferences, but I tend to use this a little bit lower level API. So what there is there's an object model called HTTP response message. So this is the WebAPI object model for the request and response. So there's an HTTP request message and an HTTP response message. And this is the object that you use to craft the result back to the client. Okay? So what we want to do here is I'm going to add a little bit of logic. What we do is we say, well, if the product is null, then I want to return my 404 status code. So the way we typically create instances of the response, it's kind of interesting. We do it through the request. There's a create response, okay? And this is a extension method off of the request object. So you, by the way, you do have the request object if you care about, you know, aspects of the request. If you want to look at the content, or there are other things. So, you know, headers, things like that. If you want to get and access those. But in terms of just sort of simple general usage, you use this request, you create the response. And what you do is you do HTTP status code, right? And we're going to say not found. So what we do is we indicate, you know, explicitly a 404 status code. If there is a product, then what we're going to do is we're going to do return request.createResponse, and we're going to do HTTP status code OK, right? And then the second parameter is the body of the response. That is the payload that is to be serialized back to the client. And again, this is the parameter that's simply an object, and it still goes through the same media type formatter stuff that I talked about earlier with content negotiation. Okay, so this shortcut syntax up here, where we return an object, essentially turns in to this line of code for you. Okay, so now if I do a build on that, and then go back to my browser and hit F5. Okay. And did I do that right? Do a build, do a control F5, and now I'm getting a 200 OK. Did I put OK somewhere? If products no, oh, I didn't do a return. All right, typical. All right, there we go. Put curlies around it so it's more obvious. Okay. Hopefully now I'm not going crazy. There we go. That's better. Okay. So that's kind of what you'd expect, right? Oh, you know, I went to some resource that's doesn't exist, then I got a 404. So this is an example of sending back a status code to indicate the outcome of the request, and you're leveraging the characteristics of HTTP to do that. Okay. All right. A really good reason for embracing HTTP, especially when we're doing these GET operations, is you get to embrace the whole caching infrastructure. That's one of the big reasons why HTTP scales, is because we have caching. And so caching can be anywhere between the client and the server. And, you know, if you're sending back the right headers, you can get the right caching behavior that you want. Clients then, if they ask for the same data, they won't come all the way to your server again and necessarily even reload from the database. Of course, caching means you have a copy, so there are trade-offs with that. But the good thing about this, though, is that if you think about the way SOAP works in WCF, is that if you want to query data, and you're doing this over the HTTP binding, it turns out that those requests are all over a post request, which typically is not going to be cacheable. So even though you might be invoking a GET operation, a query your database operation with SOAP, that's still a post. Okay, so that you're really kind of fighting against the grain of HTTP. Here, we're embracing it a little bit more. Okay. All right. So I'm going to talk a little bit more about other ways to do errors. So let me, I'll show that in a bit, okay? But anyway, this is at least the first step towards doing that, okay? All right. How do I update multiple objects in objects graph as in EF? Well, again, it's up to you, Stephen, how you want to model this. Again, usually this is modeling a resource of some sort, and you have a data structure that models that resource. How that maps back to your entity framework code, that's really kind of up to you. So if this resource has collections of child objects, and then you write the code to map that back to your EF, totally fine. Then you can do your batch updating on the server. So really, there's nothing special in here that either prevents or allows that. That's more just up to how you do the mapping yourself from these. Again, I kind of said these are like DTO, data transfer style objects. Okay, I tend to prefer, even though it tends to be more work, I tend to prefer explicit coding of these DTOs to have very tight control over what, in fact, I am sending on the network and what I will accept on the network. Okay, so actually, relating to this, let me show you doing an update. Okay, so that's the next thing. I'll come back to more questions in a minute. So the way we typically do an update is with HTTP, we use the put method. Okay, so what I'm going to do is I'm going to have a put. And so what I'll do is I will pass in my product data like this. So if you see the way I coded this is that the product data, notice it does not have an ID. I did that on purpose. Okay, a lot of demos you'll see people put the ID right in the product data. And the thing is, with our design of embracing URLs as our identifier for our resources, we don't need IDs in the actual DTO necessarily, okay? Because the IDs come in through the URLs. So with this particular signature here for this put operation, what we're expecting is, the request to be a put operation to the API products, whatever, product 1, and then the body of the request will be the, the name, whatever, chai, and the price is 10 or something. Okay, something like this. Okay, I can't spell price. Okay, so that'll be the body. Okay, if the ID were also in the body, what happens if they put the wrong ID in there? Now it's confusing, right? Is the ID here or is the ID there? And that's why, again, you see a lot of demos, especially demos where people do their direct entity framework classes right to the network. I just think that's a little bit either lazy or sloppy. I don't know. Maybe I'm too anal about it, but of course it would work. But if you're really trying to embrace this as a very, very clean architecture, then I tend to prefer this style. Okay, so what I'm doing here is I'm doing model binding. The primitive data type is going to be model bound by default from the URL, and the complex data type here is going to be model bound from the body. Right? That's just the convention that WebAPI uses. So there are directives, you can say like from body, I think, yeah. So you could actually put directives on the parameters to dictate where they're going to come from. And you can also do it like, for whatever reason, from the URI, right? You could do that. But by default, if it's a primitive type, it comes from the URL or the URI, and that includes the query string. If it's a complex type, it's going to come from the body. So we're going to get model binding here. So as long as we submit up either JSON or XML, then it will map to this class. So here what we do is we go to our query, and again, I probably could have refactored this to not have so much duplicated code, but let's do select P here like that. Let's get the product from the database. Again, if product is null, then I'm going to return a request.createResponse, HTTP status code not found. So even on the update, maybe you passed in a bad ID. We don't have that, so maybe that makes sense to say not found. And then I'll map from data.name. Okay, this is a little bit of a tedious step here because you got to map back and forth. But again, this is the same issue as in MVC when you're doing DTOs or view models or input models. Okay. What I like, though, is you have very tight control over what it is you're allowing and how you map it back. Again, maybe the data structure, the shape of the data you are exposing at your edges is totally different than the shape you're actually storing back in your database. Okay, so what do we return when we create this response? What status code do we return? I'm going to return no content. Okay? So what that means is no content is a success status code. Maybe you guys were expecting me to do OK. But what OK typically implies is that there's something in the body that's coming back. And you just sent me the data you wanted to update. I don't see any need to echo it back to the caller. So an OK implies that I'm going to send you something back in the body. I don't have anything here. So instead I'm going to send back a no content response, which if we go look at the definition here, is a 200 range status code. It is a success status code. It's just a 204, which means, yeah, great, worked. I just got nothing for you. Okay? So that's one of the things about HTTP or web APIs is that if you're only building browser-based applications up to this point, you're used to like 200 OK, maybe a 404 or 401, but there are so many status codes, and you tend to really learn a lot about the different uses of the different status codes when you are doing WebAPI. Actually, I'll just do a little bit of shameless self-promotion here. On my blog, when I was learning about all this stuff myself, I sat down and I was like, oh, okay, well, all these different code paths through your application, what status codes are meaningful for which types of results? So I have a blog post here where I actually map this out for based on all the different types of operations. So for this GET request or a POST request, here are all the different types of status codes that you could return and why you may or may not return them. So from like a put, which is an update, right, you could either do a 204, which means no content, or you could do 200 OK, which you pass the body back. Here's getting back to the prior question about errors. Bad request is typically the status code that you send back when the caller passes you bad data. So an example of this, actually, going back to my code, is what if my product data, what if like the name is required? Okay, oops. Okay, you guys have done, oh, I need to reference the data annotations library. It is referenced. And I'm not sure why I'm not getting that. System.componentmodel.data-annotations.required. Okay, weird. So maybe this is required, or maybe you have a range or something like this. Right? Okay, that one picks it up, so I'm not sure what mine. Okay, weird. So you may have a range, right, where this has to be between 0 and 100 or something like that. Okay, these are the same attributes that you can use from MVC to express your validation for your data. Okay, so it turns out WebAPI honors those as well. So when they're doing model binding down here on our put, right, they map the incoming data into this data structure. We can actually check immediately when the request comes in if the model binding was valid. Okay, so rather we care if it's not valid. Okay, so we have validation here built into WebAPI, much like MVC. Don't be fooled. This model state is not the same implementation as the one from MVC, but like I said earlier, they behave very, very similarly. So I'm going to do create response, HTTP status code, bad request. That's the 400 status code. So the 400 status code meaning it's a client error of some sort. So that's the one that people use typically, that I've seen at least, for validation types of errors. Okay. Now, in terms of the actual messages to send back to the client, this is using the right status code, but you could easily pass a body back with the bad request with some sort of error message. So I could actually just do an anonymous object with like an errors collection, and you could populate this with some sort of error, list of strings, say, with whatever your, name is required or something like that. Okay, so you could do that so that the caller actually gets some validation, information that maybe you need to present this to a user or put into a log or something. Okay, so that's one approach. You can totally do that. There's actually another one though, which is there's actually one called create error response, which, given the way the method overloading works, they just needed to change the name. So what this is, the same thing, HTTP status code bad request, and then what you would do is you'd pass the model state. Okay. So the model state already has the list of errors, and so this will serialize out the model state in a format back to the client. Okay? So if you don't like the way it's formatting, then you can either substitute with something else or do this approach I showed down here. But really, in terms of your API design, the format of that error information coming back is almost just like the format of my normal response up here when it was a success response. So the format of this, perhaps rich, verbose, additional error information is up to you. Okay, there's nothing standard in HTTP for that. The thing that's standard is you get the status code, and if you really want, you can put a status phrase with it. But that's not typically verbose enough for perhaps a human to look at. Okay, So it's up to you which of the two approaches you want to do. I'll just, well, I'll do the model state one. That's fine. Okay. All right, so you guys get the idea. Okay, now to invoke this one, I'm going to cheat a little bit here. I'm not going to yet write my C# client. I'm actually going to use Fiddler. So Fiddler is a great little HTTP debugging tool. It's actually really good for testing these services. I know it's kind of tedious sometimes, but it's a nice little tool for just quickly invoking your services. So if I go over here and in my browser, query for product, like actually let's do this one here. Well, whatever, I'll just do this one, product 1, okay? So that one, did that work? Yeah, 200 okay, and I got back my price, good. So we'll go over here into Fiddler, we'll see we made a request, okay, for product 1. So what I'm going to do is I'm going to drag this over here to this little Composer tab, and I'm going to rerun this, but instead of requesting XML, I'm going to request JSON. Okay, and I'll get rid of all this other stuff. Okay, so I just manually made a request, and the whole point of that was to get back this raw JSON, right? Mainly so I could just copy and paste it when I'm going to do my put. Okay, so that was my response. That's the format of my data. So what I'm going to now do is come in here and now do, instead of a get, I'm going to do a put. Okay, I'm going to put to product 1. That's an update. So I'll put in the body here, and I'm going to update this to be price of 20, something like that. Change it to chai, because that was the actual original value, like this. That, and then what I'm going to do is go put, and now when I make this request, I need to tell the server the format. So it's sort of like the opposite of the accept, right? So what I'm going to do is put in the content type, and I'm going to tell the server that I'm sending JSON to it. So the content type is what I'm sending up, and then the accept is what I'm asking for back. I guess you could mix and match those. It might be a little crazy, but anyway. So let me put a breakpoint here just to run this in the debugger to see if it works. Okay, so my debugger's up. Now let me go hit in Fiddler here. Let me go hit my my execute button. Okay, hit execute. Okay, great. We're in my debugger. There's my data, and we see that model binding was nice. Came through with my values. Okay, there are no validation errors, I don't think, so it is valid. Okay. I grab the back-end business models, whatever those are. Okay, map my data, save the database update, and I send back my no content. Okay. If I were to send this and pass in maybe no name at all, let's actually take the whole thing out and see if what happens here. So execute this, and now my data comes in. No name, and hopefully, yeah, notice is valid here. My validation says, nope, you're not valid anymore. We can't accept that data, and then you send back that error response. Okay. Now, the response here, like I said, is going to take model state and serialize it out. And so what we do is we look here. We get a 400 status code. If you look at the response body, then they end up giving us this message here. So the request is invalid. That's not terribly useful, but here's the model state. The model state then has the input parameter name, and then an array of the messages. Okay. So maybe you want to do this more verbose message, but so it's up to you. That's why a lot of times what I find is the model state's okay for debugging, but the way it's kind of buried in here, I actually don't really like that myself, because then what is this data parameter? Nobody really sees data because data comes from this parameter name, but it's actually the body of the request. So I usually do something to try to clean up the structure of model state a little bit to make it a little bit more presentable, whether it's either to a human or just to my own JavaScript. Okay, so I think I've covered a lot of the fundamentals of the plumbing here. You can imagine what a delete looks like. You can imagine what a post looks like. So again, a post tends to do a create. So if you were going to do a post, let me just stub that out here real quick just to give you guys an idea. So a post tends to not have the ID, tends to have just the data because it's like a create. Okay, so the request would be something like a post, but no ID parameter. Okay, so then you would do whatever you need to I'm not going to do anything right here, but you would do whatever you need to do to create the entity. okay, or the resource in your server. A delete would just have the ID. I guess I'll go ahead and stub that one out too, just because I'm talking about it. I won't bother implementing it though. You don't need to post any data, but you do need to pass the ID. Something like that. Okay, I'll leave that up to you guys if you guys feel like going and filling in those implementations. Okay, let me check the questions here real quick, and we'll see where we are. So, how does a parameter binding work with the same get method? So, with a get, you don't have a body. So, the model binding is just off of the URI. Okay, and they do some work. I don't use it that often. Let me go check here real quick. So, they tend to like, let's go call this like filter or something. Like I said, I don't tend to. I'm just going to put this in here for the heck of it. So I don't tend to use this one that much. But if we go to /API products, we get all of our data. If I type question mark, what I call it, filter. Yeah. So they actually do a little bit of sniffing on the parameters. So they try to find the best match on the parameters. So you know, again, you could imagine scenarios where this gets confused. But I've not used this myself much, but they support a certain amount of kind of like overloading, if you will. And it was smart enough to go here as opposed to then the one with the ID. Okay. So there's some amount of heuristics in there to try to guess the right one. But I myself, I just don't tend to use it that much. But yeah, it is possible. Compared to SOAP, it seems you're able to overload method names. I'm not sure what I mean by that. Well, I guess in terms of what we just talked about here, I suppose. Again, though, it's just sort of a different mindset. So I don't even know if I would think of it that way. Again, I'm thinking more about HTTP. I'm thinking about this controller as a resource, and the HTTP method are the operations that I am trying to do to this thing. In terms of parameters, yeah, overloading perhaps maybe works a little bit differently. So hopefully those answer your question. Advantages of SOAP over REST Web API. So again, I talked about this sort of at the beginning. It's really, SOAP doesn't have as much of a reach, I think, is the biggest trade-off. So if you want to write clients that run on the iPad and the iPhone and mobile devices, SOAP is a very heavyweight protocol for those devices. This HTTP, based stuff tends to be a lot lighter weight, a lot simpler to code against. Also JavaScript. Think about JavaScript invoking a SOAP endpoint. It just seems like a total nightmare to code that up. I'm sure there are libraries out there to help, but it seems unnecessarily painful to code that. SOAP has other things that this stuff doesn't, though. Like I said before, it has like the concept of transactions across multiple SOAP requests, and they have their whole they have the ability to do end-to-end message protection. So here, if you were going to protect this on the network, you need SSL, and that's a point-to-point, not necessarily end-to-end. So if for some reason this message that I'm sending has to travel 3 or 4 servers down, and I want to make sure the message is protected so that none of the intermediaries can read it, this doesn't really have support for that, whereas SOAP did. Now, did you ever use that? I don't know. I don't think I've ever come across anybody who used all those little, little tiny features of SOAP, or not tiny features, but all those little features of SOAP that seem so perhaps esoteric. So, it's trade-offs. They're different protocols. They kind of serve different purposes. Are supported serialized self-tracked. So anyway, basically with entity framework self-tracked entities. I don't actually use those myself. The problem with those is that self-tracking, I think they're serializing some sort of initial state along with it. So your entity that you get back on the wire then would have like the current values and then the original values. I don't tend to use that myself. My understanding is that it's got some flaws, so I don't tend to use that myself. So I don't really have a good answer for you. So I've the entity framework guys from the Teach and Develop Mentor tend to tell me that it doesn't work so well. So like I said, I've sort of stayed away from it. just in general, though, going back to sort of the entity framework concept as your model, you could use these entity framework classes as your DTO, but again, like I said, you're kind of, those are their job of the entity framework stuff is to model your database. Okay, the job of your service is to model your public API, and I don't always see those as one-to-one. Most designs that I've seen, you end up running into problems or flaws if you end up trying to sync those out one-to-one. So that's why people take the effort, create a view model. I mean, this is essentially, just like a view model would be from MVC for modeling your data at the wire. So, like I said, I think in the long run, the extra effort of decoupling these for the two different purposes actually will serve you well in the long run. So, but anyway, specifically self-tracking entities, I don't really know the answer to that. Sorry. Okay, this route map without action name. How would you handle a situation where you have multiple methods to update the resource? Yep. So there are a couple different things here on updating different things. So there is another HTTP method for supporting partial updates, and it's called patch. And this is introduced into HTTP, or they're attempting to introduce this into HTTP for doing like partial updates. So the WebAPI team, I don't know if I have this, Delta. See if Delta's included. Oh, I do have it. So as part of, so WebAPI has been out for about 9 months now. Every 6 months they try to do a release with new features. So it's been out for 9 months. So they've had one feature release since the initial release of WebAPI. And one of the things they released was their OData support. OData is a protocol on top of this web-based, this HTTP-based stuff for modeling like syndication, but people can use it for data and things like that. So it's on top of like the Atom Pub protocol. So the Atom Pub protocol has this notion of sending partial updates. And so to support that, they implemented this thing called Delta, Delta of T, where you can actually take a partial update. So in other words, my previous situation where my product data was missing the name, that would have actually been legal here. So because they're only sending along the price. And so that was only meant to do a partial update. So this is one approach, basically, that people have looked at or are trying to do for doing partial updates. That's one approach. The other thing, though, is that in terms of just designs, where you're thinking about changing Booleans or changing 3 properties or updating 10 properties, forgetting about this patch sort of approach, you perhaps need to think about your design differently rather than thinking about somebody updating 3 properties at a time. And this is getting more to the sort of RESTful pattern, if you will. And so I'm not necessarily have the best answer for you, but this is sort of the way I think about that. Whenever I think about, oh, they need to update these 3 properties for this scenario, what I think about is sort of like, how did people deal with doing updates to systems like this before we had computers, right? And it sounds silly, but the way I think about it is sort of like, if you were to, oh gosh, I don't know, like get a product. Say you went to Sears 50 years ago and you bought a product and you took it home, you didn't like it, and you came back and you wanted to return it. What you ended up doing is have to fill out some paperwork and submit that to the person across the counter, right? So in essence, doing an update to the original order, which tries to cancel the order or return the order or whatever it is, in essence what I've done, though, is I've not actually modified the original order. What I've done is I've actually created a new resource. The resource that I've created is now a cancellation request resource, and that tends to be the thinking about how to do like updates, kind of like what you're asking. Now that may not map exactly to the way you necessarily want to build a system, but in terms of this style of, HTTP-based systems, and again, if you are adopting this RESTful style, that is how I've come to terms in my mind with how I think about designing these systems. it's tricky because REST, there's no cookbook for REST. It's not like exactly step 1, step 2, step 3, you're done, right? It's a style, so there's no, it's not necessarily set in stone how you exactly do all these little things, okay? So again, I would think about, for your Boolean and your 3 properties, I would think about what is the user doing that they're going to have to update those 3 things at once. If you're just building an edit screen like where everything's open, yeah, I could kind of understand that. So maybe patch is a better answer for that situation. But if instead what you're doing is, because they're updating the Boolean and the 3 properties, that's all done together because they're trying to, say, cancel the order, for example, then that's more of a action-based, and I don't want to confuse the word action as in like an MVC action, but that's more of a task-based sort of system. And so if the user is doing these tasks against the system, that may not be updating your original data. That may be really another conceptual resource different than the original controller, if that makes sense. Okay? This is, like I said, kind of loosey-goosey. I don't have a cookbook for you for exactly answering, exactly how to do this. But the one book that I've read that is really good, that really kind of opened my eyes to this different style of system, on my resources page on my blog, I have some books here. And one of them is this one about building RESTful systems. It's called REST in Practice. And I don't get any money from promoting this book, so this is just pure recommendation. This book was really awesome in kind of opening my eyes to this totally different way of thinking. Okay? So this is the book that made me learn about really what REST was. That's why I was being so pedantic at the beginning. But also just, it really is good about expressing or getting you to think about the other architecture rather than a data-oriented, kind of like this table-oriented architecture, if that makes sense. Anyway, hopefully that helped. If not, sorry. Okay. Good. Thanks, Chris. Changes that are required to support OData. OData is sort of on top of the base stuff that I just talked about. There is now there are 2 big things with OData. There is the concept of the filtering. So you can actually get the OData style filtering relatively easy. All you would have to do is mark this as queryable, okay? And then you'd have to return this as an iQueryable instead. And then in the routing configuration or in the global configuration, you have to enable this queryable support. So there's like a function call that you have to do to kind of enable this. And so what that does is that'll give you the OData style query where you can actually do the oh gosh, I forget the syntax off the top of my head, but like filter, name, EQT or something like that, and that would give you the OData style filtering. Okay, and they support filters, some greater than, less than, that kind of thing. And they don't support all of OData. The next version that's going to come out in the next few months supports all of OData. So that's one piece of this is just the queryable filtering stuff. The other thing then is if you want to support sort of the full-blown OData where you have the the Atom Pub style format to your data, then there's actually there's an OData controller base class that you would derive from, and they have special methods for create, read, update, delete, and so on and so forth. Okay, what are these operations, get or post? I'm not sure what you mean. The methods here are indicating which ones we accept. So we're supporting get, and I showed you doing, I didn't actually code up the post and the delete, but I also showed put, and then I guess the 2 gets. So I just did put and 2 gets in my demo so far. How do you secure the API? Right, so securing the API, there are authorization filters. So you can do authorize. Again, this is another thing I mentioned where this looks just like the MVC authorize, but it is totally different. So make sure that when you do this one, you actually get the authorize out of system.web.http, not system.web.mvc. Oops. Well, there we go. You don't want that one, right? You want the one out of HTTP, okay? And that'll give you the right one for WebAPI. So these will do authorization. Now, in terms of how you do authentication, that's kind of up to you. We're in an HTTP-based protocol here, so you're going to want to do authentication the way HTTP does it. So there's it's actually called the authorization header, which is meant for authentication. It's kind of a bad named header in HTTP, but you could either do like basic authentication. You could actually, if this was all being hosted out of a website where you've already done like forms-based authentication and you're doing cookie-based, token, then that works. If you want to do more of a pure token-based approach, then you could do that as well. How you do all that is well beyond what WebAPI provides you with, but those are what a lot of the open source projects that I work on actually are all about, sort of answering those needs. So I actually work on an open source project called the ThinkTexture Authorization Server and the ThinkTexture Identity Model and ThinkTexture Identity Server. Those are 3 different open source projects. And if you go to GitHub, if I turn off Fiddler, if you go to GitHub, then you can see the product pages that for these open source projects that I work on. So the one most related to WebAPI is the authorization server. So the ThinkTexture Authorization Server is basically a full authorization server, OAuth 2 implementation that we worked on, and it's pretty nifty in that you can set up your how you want to secure your web APIs, and clients can come and follow the whole OAuth 2 protocol for obtaining a token to then invoke your web APIs. Again, that's kind of beyond the scope of what the talk is today, but that's, I guess, another plug for the kind of stuff I work on. This is open source, so you can go look at it, download it, compile it, change it, whatever, use it in your projects, and you can get OAuth support in your web APIs. Okay. All right. Is it easier or possible to handle hierarchical structures in a single call? Yeah, sure. So that's up to your DTO. So the structure of this is whatever gets sent back. So you can have this data type that you're sending back and forth be however arbitrarily complex. Again, it has to map to typically JSON or XML, so it has to be a tree structure, not a circular graph, even though some of those libraries do support serializing out circular graphs, but you imagine like a JavaScript client trying to consume that, that might be a problem. So, okay. So some of those queries wouldn't line up with the database if you're doing DTOs. You're absolutely right. So that's sort of that's why I said doing a DTO style actually is a little bit harder, a little bit more work. You definitely have to figure out how to line those queries up. You're absolutely right. All right. What's the preferred way to host the API? So I don't know if I mentioned this explicitly, or maybe I did, but Web API can be hosted in either IIS or something called self-hosted. So self-hosted is where you host it outside of IIS, like it could be a Windows service or a console app even or whatever. So you can totally do that as well. In terms of what you prefer, that's really up to you and your requirements in your environment. If you already have IIS in your environment and you are if you already have IIS in your environment and you are already comfortable with that, then IIS is fine. If you just need to host on this on some server that doesn't already have IIS, then you could do self-hosting. That's just kind of up to you and how you want to decide that. All right, so we're running out of time here. I want to show you the client processing model just real quick. So I just want to illustrate that for you here. So what I'm going to do is I'm going to run Visual Studio again here, and I'm going to create a console application to invoke my service. And I only have I think a put and a get method so far, so I don't have necessarily a full-blown service, but just some mechanics. I can show you some basic mechanics. So what I'm going to do is I'm going to create a console application. Okay, so this is going to be my Web API client, and so really, to be a client of a Web API, you just have to have an HTTP stack. So that's why I'm not going to bother showing you a browser-based JavaScript client, because I'm just assuming most of you people already know how to do, AJAX with jQuery, or maybe you don't even care about that. So, but the console-based or a .NET-based client is a little bit perhaps more new to people. So that's why I want to show that. So you can just use any HTTP stack. So again, from JavaScript, you can use jQuery or just use, the XML HTTP request that's built into the browser. That's fine. If you're doing something like a .NET client, then you can use whatever HTTP stack you want. They did come out with a new library, though, that is supposed to sort of line up with the server-side library. So that's what's really new here to show. But really, you could use anything. So there's the web request class that's been in .NET since 1.0. So what's new is the HTTP client. This is the new library then that is meant to provide you a more kind of resource-oriented view of HTTP. So here are the HTTP client libraries, and what I want are, I think that's the right one, although I'm missing the formatting. HTTP client. Oh no, this is it. I guess they changed their icon. All right, now I'm going to be confused about which one's which here. WebAPI client libraries. They just did some updates on this in the last few days. So, you know what? I'm going to grab this and we'll see if this is the right one. Oh yeah, it's pulling Newtonsoft. Good. Okay. All right. Good. I think that's the right one. All right. So, oh yeah, it pulled in the formatting. Okay. Good. This is what I want. So what they have is this new client library. Okay, so HTTP client. So what you can do then is you see on the client, they have, I can't spell anymore. They have very easy methods that map to the types of operations. So get, put, right, post, and delete. And you know what, do they even support patch yet? No, they don't have patch support yet. So, but they have the four major verbs that you would tend to use, okay? So the idea here then is that this client library kind of mirrors the server-side library. And the other thing about this, though, by the way, is that like when you make a request or a response, the object model that's being used by this HTTP client library is actually the same HTTP request and response classes that are being used by the server-side library. So you could actually, in theory, set up a client that actually invokes directly to the service in memory. So without even going on the network, they can get wired up to each other, and they look like, you know, they kind of think from each side that they're coming in over the network. So anyway, you could do like full end-to-end in-memory unit testing, fully exercising the APIs. That's kind of why they designed it that way. Anyway, so this is the HTTP client, the client-side library for doing this. So I'll just do the simple stuff. We'll just do a get, okay? So what I'm going to do is I'm going to do a get async. And I'll put in the URL, which I've already forgotten what that is, so API products, okay? So that's going to be my URL. So I'm going to do a get, okay? So the thing with the get, though, if you notice, it is a sync. So that's actually a feature of these is they assume, well, these are IO-bound calls. So they bake in the concept of these being asynchronous. So there are no synchronous versions. You have to go through the async version. Now, this is good if you're in a server environment where you then want to relinquish your thread back to the server while you're waiting for the I/O, or you're in a UI where you want to relinquish control back to the user while you're waiting on the I/O bound work. That's super important. I'm in a console app, so I'm going to fudge it and just be lazy. But in a more realistic environment, you would be embracing the async style. And this also means you could totally do the async and await keywords that are new in C#. So for here, I'm just going to do the .result. This will actually block waiting for that IO bound call to return. Okay? So this result, though, if you look, is an HTTP response message, and that's the same class that we had from over here in my server-side code. Okay? So you know what? I never enabled my queryable support. I don't think that's going to be happy. So let's just put this back to IEnumerable. Oh, actually, well, that's fine. Didn't matter. Okay, we'll just do a build here and rerun my code. And oh, I guess there's your authorization that you asked for right there. Okay, cool. So I'm going to make that request. So Web API demo. Go to the client, API client. So I made that request. Oh, I got the right URL already. So the result then comes back and it tells you if, we can do something like console write line of the status code. Okay? So we'll do result dot status code. Okay? So that tells you okay or not found, something like that. Okay? So then what I'm going to do is I can do something like if the result is a success status code, okay, then what I can do is I can get to the payload, the content, if you will. So I can go to the results.content, and I can then read the body of the response. Okay, so they have several overloads. You can read it as a stream, right? Maybe the data coming back is like an image or something. We can read it as a string, which in this case is going to be probably as JSON. So I'll read this as a string, and again, that's async as well, so I'll wait on the result. Okay, so this is the actual JSON coming back. Okay. Oh, this is not a method; it's a property. So there's my JSON. Okay. If you want to, you can. By default, I didn't put the accept header here, but by default, the server, if you don't ask for anything, it does return JSON. If I wanted to be really, if you wanted to be really, explicit about it, then you could set the accept header. And you could say something like, I'm accepting the application, JSON, something like this, right? You can be really explicit and say what you wanted to accept. So there's my JSON, and so now what I have is the back of a raw JSON string. Now what I want to do is turn this into something that I can work with programmatically. So there are a few different ways to do this. One is, again, this is leveraging the Newtonsoft library, so we can actually use that, Newtonsoft, JSON, and JSON serializer. No, JSON. Oh, it's called JSON convert, I think. Convert, yes. So we can actually deserialize object. Okay. So I can deserialize this JSON into some strongly typed object. Okay, and so it's a generic type here. So if you have a strongly typed class that shapes up with the JSON, then you can do that. So there are a couple of different ways we can do that. We could share our DTO. Let me go back to my server. I could literally copy this, go over here to my client code, paste it in, and then do that. Okay. There's actually a nifty thing that Microsoft did in. Let me show this to you. It's pretty cool. It's almost a little silly. Let me grab it here. If we go to, I want to grab this as JSON, is what I want. There we go. So there's my JSON. So if I copy this JSON, right, that's the shape of an example of one. In Visual Studio, they now have, if I can find it, edit, paste special, paste JSON as classes. So in my clipboard, I have that JSON structure. If I paste it as a class, it actually takes the JSON and then paste it into Visual Studio as the right shape, right? So that you can now have a strongly typed class to then do your deserialization. It's kind of funny that they added that. Anyway, some tooling like this, the whole idea was to make the tooling support better for this sort of style to help win over like the SOAP developers who are used to the tooling. So I'll just call this product. And then what I'll do is I'll do deserialize as an array of products. Okay. And then I'll do for each var p in products console write line of the name and the price. Okay, so I'm going to build this, and if I run this, hopefully I'm able to get my data, which I was not. Input string was not a correct format. Where is this? Parse int 32. Interesting. So, something about my parsing failed. Oh, in the Newtonsoft library. Let's just print out the JSON. I'm wondering if I got some sort of funny shape data. I might have gotten null. Did I get null somewhere? You know what? Oh, int price. Ah, it was doing this as a number, not a decimal. Okay. And you know what? I think it's nullable as well. So it looks like that paste didn't quite know the right thing to do. We'll see if this makes it any better. Ah, better. Okay, good. So I didn't even notice it was an int when I pasted it in there. Anyway, so yeah. maybe the tooling story is not so great yet. But anyway, there we go. We got our data. Okay, so it came back as JSON, and I turned it into a bunch of objects. Okay, so it turns out there's actually a shortcut. I was doing this sort of the long way to just show you the steps involved. On the result content, you can do read as async here, where you actually just pass in the data type you want. So product array, like that. And that will actually just give you back the result. Like that. Okay? So anyway, I was just showing you this. There is a shortcut that basically does what I did for you in a long way. Okay? So you guys get the idea. If you then want to post data, something like this, you can do client, you can do put. So you could either put async, and when you do a put async, okay, you could either pass in content, right? This is a little bit lower level version of the API, or as you can tell, there are overloads where you can do put async, where you actually pass in an object. So you actually pass in the URL, and we pass this in like it's a product like this. So you actually put in the URL and then the actual product object, and they would then map that then to the right, to the body of the request. Okay. So we're running out of time, so I have to kind of wrap this up. But anyway, hopefully this gives you a little bit of idea about the client-side library, and hopefully server-side as well. You guys have a better idea about the whole concept of using WebAPI for API controllers, and sort of how you would go about building these things. I know this wasn't, totally about the design of how you design every little type of scenario, but hopefully this is enough of a starting point where you can think about how to build these services based on HTTP, change your thinking a little bit about making more of a resource-oriented architecture rather than a sort of RPC function call-oriented approach, and how WebAPI fits into that picture. I'll take a couple more questions here, and then we'll call it a day. So no, there is no WSDL-like setup for WebAPI. OData has something kind of like that, but but no, in general, no, this is all very convention-based. So you tend to, as a consumer, you tend to look at docs and you see the shape, kind of like I showed you here a minute ago, right? They'll see a lot of examples of like shapes of data coming back, and you kind of code around that. That tends to be, like I said, sort of the pattern. There is some support for WebAPI building documentation. They have this thing called an API Explorer, which is basically like an object model that interrogates your controllers and then gives you back an object model that describes the shape of your data, so that you could help automate building that sort of documentation. So that was in the recent release about 6 months ago. And yes, thanks, Mike. We found out my bug there. So, okay. So again, looks like that's it for questions. So thanks again, everybody. Thanks for coming. I hope that was useful. And if you have any questions, feel free to contact me. The slides have a lot of this data in it, and I will paste in the demos real quick here for you one last time. And so I'll zip up my demos and put them up with that URL. But if you have any further questions, feel free to shoot me an email. Other than that, thanks for coming. See you next time.